Well, Happy New Year, class, and welcome back to Honors Algebra 7. And for those students who've never seen a video, this is kind of how the flipped classroom works. I kind of talk, and my lecture comes through this video of Chapter 7.2, Solve Linear Systems by Substitution. So my lecture or my talk in front of the class that I had today, you won't see very often that I stand up for the amount of time that I did today, because usually all the information comes through the video. And if you have any questions, you can ask me through email or the next day in class, obviously. But you can always ask questions ahead of time. So on 7.2, let's look back now a little bit from what you did today on 7.1. Okay, you were given a system of equations and you had to graph them. So they usually started in standard form. You got into y equals mx plus b form. And at that point, that's where I told you can kind of visualize where those two lines would intersect each other and find out where they do intersect. Now today's a little bit different though. We're not graphing. For the next couple sections, you will not be graphing at all. We'll be solving it algebraically. So very similar idea. We're still looking for that intersection point, or if it's a no solution, if it's parallel or many solutions, infinite many solutions, if they're the same line. But today we're in a solve, well, in chapter 7.2 through 7.4, we're solving them algebraically. So let's get started. So steps to solving using substitution. In step 1, you're going to solve one of the equations for one of its variables. Okay? So, when we graph, we always want to get y equals mx plus b. So we're solving for y here. Okay, to get one of its variables alone. And the coefficient on this y is 1. Okay, it's the number that appears before the variable, and on y equals mx plus b, the coefficient of 1. So we want to get a variable by itself and have a coefficient of 1. Here it says -1 as well, which we could, but we're going to get rid of that -1 that appears. So solve one of the equations for one of its variables. So we're used to solving y for y equals mx plus b, but they're saying now that you could solve for x. You could get x alone here. Okay, so we'll talk about that. It'll be a little bit easier to see it when you have a problem to work on. So step 2, substitute the expression from step 1. So what we solve for, either x or y, we're going to substitute it back into the other equation and solve for the other variable. Okay, this will all make sense in 1 second. And then substitute the variable from step 2 into the revised equation from step 1 and solve. So let's take a look at the steps by solving a problem. So y equals 3x plus 2 and y plus 2y. I'm sorry here, this is supposed to be an x. So let me erase that. So x plus 2y equals 11. Okay, so step 1 says to solve one of the equations for one of its variables. So let's say this is equation 1 and this is equation 2. So it says solve for one of its variables. Well, what we notice here in this first one is that y is already solved. Y is already alone. We know that y equals 3x plus 2. So step 1, where it says to solve one of the equations for one of its variables, it's kind of already done for us in this problem because y is alone. So now we know what y equals. So step 2 says substitute the expression from step 1 into the other equation and solve for the other variable. So we solved for y here. So we're going to plug in what y equals in for y, and we're going to solve for the variable x. So we know that y equals 3x plus 2. So in the second equation, it's x plus 2, parentheses now, 3x plus 2 equals 11. Okay, so I solved for y. Well, y was already solved for us. I'm plugging in that information in for y into the second equation so that I can solve for x. So if I solve this now, you're just solving this algebraically like you learned probably in the first couple chapters of the book. Okay, so x plus 6x plus 4 equals 11. Combine these together. Minus 4 over 7x equals 7. Divide by 7. X equals 1. So again, we're trying to find out where these two lines intersect each other, and we can't use it graphing, so we're going to use it algebraically. So we know our x is 1. So what they say now in step 3 is substitute the value from step 2, so which is 1, into the revised equation from step 1 and solve. So our first equation is y equals 3x plus 2. We're substituting what we found for x in for x, so y equals 3 times 1 plus 2, which we know that 3 times 1 is 3 plus 2 is 5. So we know that these two lines, if we graph them, they would intersect at point 1, 5. Okay, and you could check it if you want, which I highly recommend. Plug in 3. Here, let me erase this for a second. We know that 3 times 1 is 5 plus 2, or I'm sorry, 3 times 1 is 3 plus 2 is 5. So that one checks out. We know that, remember this is an x here, sorry. 5 times 2, because this 5 is y, 5 times 2 is 10, plus x, which is 1. So 5 times 2 is 10, plus 1 is 11, so that checks out as well. Okay, so we're trying to find that intersection point. So let's look here. X minus 2y equals negative 6 is the first system of equation, and 4x plus 6y equals 4 is the second equation. Okay, so step 1, we have to get one of these by itself. And remember the recommendation here. It says to solve for a variable that has a coefficient of 1 or negative 1. So if we go back here, we know the coefficient on this x is 1. So let's solve to get x alone. That's the easiest way. So it's only a one-step problem. We're going to add 2y over. So I know that x equals 2y minus 6. Now, we solved for x, so we're going to take this part of the equation and plug it in for x. Okay, so that we can get y alone, the opposite one. So 4, 2y minus 6, plus 6y equals 4. Now we just solve this algebraically. Okay, combine like terms. I'll combine these here, and I'm going to add the 24 over. I'm going to kind of do 2 steps at once. So we get 14y equals 20. That's adding here. 28 divided by 14, y equals 2. So we know in our ordered pair here, y equals 2. Now the equation, this was kind of step 1 here. Step 2 right here. Now step 3 says go back to step 1. Take your revised equation and plug 2 in for the variable. So x equals 2 times 2 minus 6. So x equals 4 minus 6, which x equals negative 2 then. So if we're going to graph these two, we know that they would intersect at negative 2, 2. So again, step 1, get one of the variables by itself on one of the equations. Find out which one would be the easiest. Step 2, okay, plug in your revised part of the equation for that opposite variable that you solved for in that other equation system, number 2, which we did down here, and then use that revised equation right here to find out what that other variable equals. So let's try another one. Example number 3. Look at the equations first. Here's equation 1, here's equation 2. Either of these have a coefficient of 1, and we see that the y does on this one. So we want to solve for y on the top. So we get negative 5x minus 1y equals 12. So add 5x over, negative 1y equals 5x plus 12. Now, remember, we want a positive, so we divide by negative 1 here. We know that y equals negative 5x minus 12. Okay. Now I solve for y. So I'm going to take my information in, plug it in for that y so that I can solve for x. So 3x minus 5 times negative 5x, oops, minus 12 equals 4. So solve this out now algebraically. So we get 28 here when we combine like terms. Subtract the 60. We get equals negative 56 divided by 28. X equals negative 2. So remember, we're trying to find an ordered pair. So take your answer from this and plug it back into your revised. So y equals negative 5 times negative 2 minus 12. So y equals 10 minus 12, which y equals negative 2. Okay? So again, step 1, look at the equations, see which one may have a coefficient of a negative 1 or a positive 1. Solve for that variable, which we did here. Take that variable, plug it in for the other variable in the second equation. Solve for that common variable then, which we did was x, and then plug it back into the revised equation to get what that other variable equals, so you get your ordered pair. And here's your homework. You have 2 problems. Here's the first system of equations, and here's the second problem here. Okay? So if you have any questions, please feel free to email me this evening. But again, just make sure that you revisit, okay, the directions, and maybe have to watch over again, you know, some of the problems that we solved if you have any questions on the two homework problems. Now again, make sure you're taking all these notes down. It's very important. And I will check these tomorrow in class. Okay, so I hope you have a wonderful evening. Let me know if you need anything. Take care.